Hello friends, and welcome to Webronaq. Here's a question for you. Imagine you are stacking dinner plates. You put one down, then another on top, then another. When you need a plate, which one do you grab? The one on top, right? You never pull from the middle or the bottom. That is exactly how a stack data structure works in programming. It follows one simple rule. The last item you put in is the first one you take out. This idea turns out to be incredibly useful in software, from how your programming language manages function calls to how your text editor handles undo. In this video, we will break down exactly what a stack is, how to use it in C++, and where you will actually reach for it in real code. Let us get into it. Alright, let us lock in the mental model. A stack is an abstract data structure that follows the LIFO principle. LIFO stands for last in, first out. Think of the plate analogy again. The last plate you stacked is the first one you remove. On the left here, you can see a stack holding the values 10, 20, 30, and 40. The number 40 is on top, so it is the next one to come off. Now contrast that with the queue on the right. A queue is FIFO, meaning first in, first out, like a line at a coffee shop. The first person in is the first one served. Both are fundamental data structures, but they serve different purposes. The stack is all about reversing order and tracking the most recent item. Keep that LIFO rule in mind, because everything else we cover builds directly on it. Now let us meet the 4 operations every stack supports. First is push. Push adds a new element to the top of the stack. Second is pop. Pop removes the element currently sitting on top. Notice that pop changes the stack. It does not return the value in the C++ standard library, it just removes it. Third is top, sometimes called peek. Top lets you read the top element without removing it, so you can look before you act. Fourth is empty. Empty checks whether the stack has 0 elements and returns true or false. All 4 operations run in big O of one time. No matter how many elements are in the stack, each operation takes the same constant amount of work. That efficiency is one of the main reasons stacks are so widely used. Next, let us see exactly how to use them in real C++ code. Let me show you how all of this looks in real C++ code. You include the stack header at the top of your file. Then you declare a stack of integers like this, std::: stack of int, then your variable name. To push values, you call s.push with the value you want to add. In the example here, we push 10, then 20, then 30. Because of LIFO, 30 is now on top. Calling s.top gives us 30, so cout prints 30. Then s.pop removes that 30. Now 20 is on top, and calling s.top again prints 20. The standard library stack wraps whatever underlying container you choose, defaulting to a dequay. Simple, readable, and efficient. Next, let us look at where stacks show up in the real world. Here is the interesting part. Stacks are not just a textbook idea, they solve real problems every day. First, the function call stack. Every time your program calls a function, the runtime pushes a frame onto the call stack. When that function returns, the frame is popped off. That is why deep recursion can cause a stack overflow. Second, undo and redo. Applications like text editors push every action onto a history stack. Pressing undo pops the last action and reverses it. Third, balanced parentheses checking. When a compiler reads your source code, it pushes every opening bracket onto a stack. Each closing bracket is matched by popping. If the stack is empty at the end and every pair matched, the expression is balanced. 3 very different problems. 1 elegant solution. Coming up, we will tie everything together with a clean summary. Alright, let us bring it all together. A stack is a LIFO data structure. Last in, first out. The 4 core operations are push, pop, top, and empty. Every single one runs in big O of 1, constant time. In C++, you get a ready-made stack through std::: stack in the stack header. No need to build one from scratch. Stacks power function call management, undo and redo systems, and bracket validation, just to name a few. If this clicked for you, the natural next steps are queues, which flip the order to FIFO, and recursion, which relies directly on the call stack you now understand. Give the video a like and subscribe so you do not miss what is coming next. Thanks for watching, and I will see you in the next one.